All right, this is the third and final review video to help you with your review packet. This is the part that is most of our new stuff with solving different types of equations. So you'll notice that each one of these has a place to check your answer. You're looking to see if any roots were extraneous. Keep in mind that you should in math class always check every answer, but we're not always in the habit of doing that. So just giving you an extra reminder that you should be checking out for those, especially when dealing with kind of different types of equations. So for this polynomial to start, we have 27x to the third minus 64 equals 0. I know that I'm looking for 3 answers. The reason I know I need 3 answers is because of the degree of my polynomial. So looking at this, I have the difference of 2 perfect cubes. This first thing is going to be 3x that has been cubed, and this second term is going to be 4 that has been cubed is equal to 0. So I know that this will factor using the shortcut of same, opposite, always positive. It's just a shortcut. It actually does factor, though, if you go through and distribute. So the same sign, the opposite sign, and the always positive sign. And then to fill in these pieces, it's going to be the 3x, the 4, the 3x squared, the 4 squared, and then the two things multiplied together, 3x times 4. Now, if you want to check it, you can. 3x times 9x squared gets you 27x cubed. This then is going to be 36x, but then x squared, sorry. This is going to be minus 36x squared, so those are going to cancel, and then we're going to end up with 4 times 16, which is 64. All right, so this then is going to be x equals 4/3. That's not so bad. This one right here is going to need the quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So this looks like it definitely should clean up. 4 times 9 times 16. Oh my goodness. Let me grab my calculator. That's not one that I know off the top of my head. Where's my calculator? So I know, though, this is going to be negative 12 plus or minus. This is going to be 18 on the bottom. Here's my calculator, handy dandy. Quit out of there. We are looking for 144 minus 4 times 9 times 16. Survey says negative 432. All right, well, I know an I is going to come out of there. So x equals negative 12 plus or minus I. Square root of 432, if I break that down out of 4, it's going to be 108. But then 108 can break down even further to be 9 and 12, and then 12 can break down further into 4 and 3. My goodness. So it looks like I have a perfect square of a 2, and a 3. So 2, 2, 3. And this lonely 3 is stuck underneath the radical. All of this is over 18. I don't know what that mark was. So negative 12 plus or minus 2 times 2 is 4 times 3 is 12. 12i root 3 all over 18. I can take a 6 out of each one of those. So I'm all over the place. I apologize. This is going to be negative 2 plus or minus 2 root 3 all over 3. So again, I was supposed to have 3 answers. One of them was 4/3. That one was not bad. This other one, kind of a doozy. Plus 2 root 3 to I root 3. And negative 2 minus 2i root 3 over 3. Now, the other reason I know that 2 of these should be imaginary is this quadratic will always be something that has imaginary roots. Because if you think about this original graph, this is just your Disco Man graph that's been stretched by a factor of 27. So it's really tall and skinny, and then moved down 64. So it's a real tall, skinny graph, and it's going to cross the x-axis only once. That's at that 4/3. The other two are going to be imaginary. Now, checking your answers, you can plug them back in, but this is a polynomial, so domain is all real numbers. We should be good to go. All right, next one, absolute value. Absolute value, remember, is the distance between two things. So I could say that my distance was greater than 0, which would be the positive version, or I could say that my distance was less than 0, which would be the negative version. So solving this, I would say 6x equals 14, x is equal to 7/3, or 6x equals -6, x is equal to -1. Now, checking those answers, if you plug them back in, our domain of absolute value is all real numbers, and the fact that we have a constant on the other side of it means that both of these numbers will, in fact, work to make this a true statement. All right, rationals. I choose to clear my denominators, so my least common denominator here is going to be 6x. So I'm going to multiply everything by 6x. So this will become 24x over x minus 30x over 3 equals 6x squared over 6. And the purpose in multiplying by that denominator was that all of these things are going to simplify somehow. So 24 minus 10x equals x squared. Now I just have a quadratic. This one should factor pretty nicely. X plus 12, x minus 2, x equals -12, x equals 2. Now this one you need to check because of this rational equation you started with. And there's two ways you can check. You can either plug -12 back in, make sure it works, plug 2 back in, make sure it works, or you can look and say, well, dividing by 0 is a no-no in mathematics. The only number that would be extraneous is x equals 0. Were either of my answers x equals 0? No, in which case they both work. But you got to be pretty savvy with your domain knowledge to do that. So if you're not confident in that, just go ahead and plug them in and test. All right, this next one is x to the 4th, but we don't have 4 terms to group. I don't really want to go through and on my calculator have to graph and try to find the roots. In fact, when you do that, you don't get any nice roots. So what you want to notice here is that this is in a similar structure to a quadratic. But instead of having x, you have x squared, you have x to the 4th. So I'd be looking for things that multiply to -6 and add to +5. Well, that's going to be 6x squared minus x squared. And I still have this 2x to the 4th plus 6x squared, and there's -3. Now I can factor by grouping. So these two things together, I'm going to take out a 2x squared, be left with x squared plus 3. This one I'm going to take out a -1, I'm be left with x squared plus 3. I know factoring by grouping just worked because my terms in the parentheses are the same as I wanted them to be. So solving this, 2x squared minus 1 equals 0. That would mean x squared equals 1/2. X equals plus or minus the square root of 1/2. Wait for it, plus or minus the square root of 2 over 2. Almost a unit circle value. What? That is a unit circle value. Sines, cosines. It's amazing how it returns. This one then you're going to end up with x squared equals -3. So x will equal plus or minus I root 3. Again, this one started as a polynomial, so unless you made a mistake somewhere along the way, you do not have any domain restrictions that are going to create an extraneous solution. All right, this next one, absolute value. So remember, you want to think about absolute value. In one sense, your distance, x minus 10, could have been greater than 0, in which case this side stays positive, or your distance, x minus 10, could have been less than 0, in which case this side becomes negative. Now I know Mrs. Logus has you put the negative on this side. It doesn't actually matter as long as you turn one side negative. So to solve this, I'm going to say x squared minus, not minus 10x, minus 11x plus 10 is going to be equal to 0. So this one factors into x minus 10, x minus 1, x is equal to 10, x is equal to 1. I'll come back to check those in just a second. On this one, I'm going to end up with x minus 10 equals -x squared plus 10x. So x squared, I'm going to subtract 10x. This would be minus 9x minus 10 equals 0. Things that multiply to -10 and add to -9. X minus 10, x plus 1. So x is equal to 10, x is equal to -1. Now I need to do some checking. And the reason I need to check here especially is because looking at this, it's kind of hard to tell your domain, other than the fact that this side must be positive, because you're going to take the absolute value of this side, which will result in a positive number. So if I plug in, let's say 10, 10 minus 10 is 0, great. 0 would be equal to 100 minus 100, which is 0, 0 equals 0. 10 works. Success. Next one, if I plug in 1, 1 minus 10 is -9, absolute value would be positive 9. Plugging in 1 squared is 1, minus 10 is -9. Bummer, doesn't work. This one, x equals 10, wait a second, I already did that. Okay, that's good. This one, x equals -1, -1 minus 10 is -11, absolute value is 11. -1 squared is 1, minus a -10 becomes positive, 11 equals 11, that one works. So we end up with two answers, x equals 10, x equals -1. All right, last one, we have another rational. So I'm going to choose to multiply by my least common denominator. You could say that you wanted to multiply by x squared minus 9 times x plus 3, but that's not a least common denominator, that's just a common denominator. Our least common denominator, if you think about x squared minus 9, that breaks down into x minus 3 and x plus 3. So that's like having 12 in the denominator and saying that's the same as 3 times 4. So I could use either one of those when it comes to working to find my denominator. If I had something over 3, my least common denominator is 12, because 3 goes into 12, in the same way that x plus 3 goes into x squared plus 9. Okay, so I'm going to multiply by just the x squared minus 9, just like I would have multiplied this fraction one with numbers by just 12. Multiplying this in, I get 6 times x squared minus 9 over x squared minus 9 plus x squared minus 9 over x plus 3 equals x squared minus 9. Cancel. This would have been x plus 3, x minus 3. Cancel those. We'll end up with x minus 3 equals x squared minus 9. So solving this quadratic, x squared minus x, 6 together, and that is 3. Move that over, minus 12. So this becomes x minus equals 0. This becomes x minus 4 and x plus 3 equals 0. And I end up with x equals 4, x equals -3. So again, two ways to check your answers. The first way is to just plug in the value itself. So if I plug in 4 to this fraction, I get an okay answer. When I plug in -3 into this equation, -3 minus 3, or -3 plus 3 is 0. And even more so, -3 squared minus 9 is 0. Dividing by 0, can't do it. So x equals -3 is extraneous. The other way you could have found out that it's extraneous is from the very beginning of the problem. Your domain here is all real numbers, but x can't be equal to 3 or -3. So when you get to a point and you're trying to tell the world, hey, x should be -3, no, it can't be, because it couldn't have ever been in the domain to begin with. All right, lots of little tips and tricks in there. Hopefully you're grasping the concepts. If not, visit the MRC, go talk to your teacher, and good luck on your cumulative test number 3.